This lesson will be about dividing polynomials by a binomial, and we'll also add on what's called the factor theorem to this. So let's review first of all polynomial long division. If we're going to take x plus 2 as our divisor into the dividend x squared minus 6x minus 25, we first think x times what gives me the x squared, and that's an x, so x times x is x squared, x times 2 is a 2x. Then we're going to subtract the polynomial. So subtract straight down, you have no more x squareds. Negative 6x minus 2x is negative 8x. Bring down the next term, negative 25. Now we're going to ask the same question. X times what gives me the negative 8x? That's going to be a negative 8. Negative 8 times x is negative 8x. Negative 8 times 2 is negative 16. We're going to subtract those two. Be careful with subtracting the negative. That's going to be positive when we're combining it with that negative 25. So as we take negative 25 plus 16, we get a negative 9. So our remainder is negative 9. So we write out the answer as the quotient, x minus 8, plus the remainder over the divisor, x plus 2, for our final answer. Now we're going to take this process, because this is just an iterative process. You keep doing the same things. What do you multiply to get a certain thing? Find that, subtract, bring down the next term. Well, we can simplify that by eliminating, getting rid of the variables, and then setting up a new system called synthetic division that will really speed up the process of doing this division. So synthetic division, you've got to remember you've got a certain setup you've got to do, and then you've got a procedure to follow. So the setup is we're going to put the terms in order, and then we're going to put in 0 as a placeholder for missing terms. Next, we want to get rid of the variables. Okay, this is going to seem a little different because the variables are what make the polynomial expand into many different terms, but we're going to get rid of them and just list the coefficients. Next, I'm going to call it a box, but really it's kind of a backwards L, but we're going to take and we're going to write in the box the opposite of the constant in the divisor. Now, why we're doing the opposite is this will create, when we do synthetic division, we're going to be adding straight down, which simplifies the process. The mistakes people make in polynomial long division is often because subtraction, they make mistakes on. So we're going to take the opposite of the constant in the divisor, and now we're going to be able to add things straight down in order to do the problem. That's going to get rid of a lot of the mistakes that we will make in the process. Fourth step is to leave a space, so that means a whole line we're going to leave blank, and then draw a line. All right, so that's our setup. Next, what we're going to do is we're going to do the procedure for actually doing the problem. So let me show you the setup on this first one, and then I'll talk through what the procedure is. So in this first one, when we have x squared minus 6x minus 25 divided by x plus 2, the three ways we can write this problem, just so you're aware, we could write it as a fraction, x squared minus 6x minus 25, with the fraction bar serving as our division symbol over x plus 2. And the other way is to write it as a trinomial, x squared minus 6x minus 25, times a binomial, x plus 2, but to a negative 1 power, because that negative 1 power means reciprocal. So it operates the same way as this fraction does. Now you'll see the problem in one of these three forms. When we see that, we're going to take our dividend here, we're going to strip off the variables. So the first thing we'll do is write the coefficients. Coefficient of x squared is 1. Coefficient of negative 6x is negative 6. Coefficient of negative 25, the constant is just negative 25. Now I'm going to draw a little box over here. It's like a backwards L. And in that, I'm going to put the opposite of the number here. In essence, it's the root of this binomial, because if you put a negative 2 into this, it would give you a 0 for that factor. So if I take the opposite, I'll put a negative 2 in this box, leave a line blank, and draw a line. Now, that's our setup. We've got it all ready to go. The next 3 steps are the procedure we'll use. The first one is the one that people forget the most. So I'm going to put a box around this one because you want to bring the first number down. So the first number gets brought down. I'm going to put a box around this. I'll put past the line, okay, just to make sure we know where we're bringing it down to. So that line we put in there, got to make sure you bring that first number all the way past the line. So this one, you skip this empty space here and bring it all the way down past the line. Next, you're going to multiply, add, and repeat. So what that's is we're going to take this negative 2, and when we go with anything in the box, we're going to be multiplying by that negative 2. So negative 2 times 1 gives me a negative 2. You fill in this spot right below the next coefficient. And so, I'm sorry, underneath the next coefficient, underneath the negative 6. And notice now, we're going to add straight down. We're not going to subtract, which causes mistakes. If you add straight down, you get just a negative 8. That negative 8 times negative 2 is a negative 16, is a positive 16. When I add straight down, I get the negative 9. Notice that these are the coefficients of the problem we did with the polynomial long division. We had a 1 in front of the x, then a negative 8, and our remainder was negative 9. This last number serves as our remainder. So what we have to do lastly, the last step here, is we have to reinsert the variables. Now this is critical. This is another part people forget. You're going to start with 1 degree less than the original dividend that we had. Okay, so for this, x squared was our original dividend, the largest degree of it. We're going to start 1 degree less than it. So this will be a 1x minus 8, because we go down in degree for each term. Our last one's the remainder, so we write plus negative 9 over our original divisor, x plus 2. So this is our answer, which matches our polynomial long division problem. Let's try practicing this a few times. Let's do these other examples. First, we're going to do the setup, strip off the variables, write out the coefficients. So 1, 14, negative 10, no missing coefficients, so we're all set. In the box, we're going to put the opposite of the number, so a positive 6. Skip a line, draw a line, bring the 1 past the line, take 6 times 1, that gives me a 6, write it in the next spot. Add straight down, you get a 20. 6 times the 20 gives me a 120. Add straight down, you get a 110. The last number is your remainder. Start your final answer for the quotient with 1 degree less than that x squared. So it's going to be 1x plus 20 plus the 110 over our divisor, x minus 6. All right, now in this next one, we're going to up it a little bit. We're going to go ahead and start with an x cubed. Now what's nice about these with polynomial long division, this would mean that our problem would go longer and longer. All we do is we expand out our line of coefficients here. Strip off the variables. We have no missing terms. So we're going to have a 1, a negative 4, a 6, and a negative 4 for our coefficients of the dividend. put in the opposite of this number here, so a 2 goes in the box, skip a line and draw a line, bring the 1 down below, multiply whenever you use the number in the box, so 2 times 1 gives me a 2, add straight down, you get a -2, multiply these two together because we're using the number in the box, gives me a -4, add straight down, you get a 2, multiply by that 2, you get a 4, add straight down, you get a 0. When you get 0 as a remainder, just a note here, 0 as a remainder means that it's a factor. Okay, there is no remainder on this, so we've got the quotient being a factor of the original dividend. So let's write it out. I'm going to start with 1 degree less than the x cubed. That'll give me an x squared. So 1x squared minus 2x plus 2. And then I don't write out plus 0 over the divisor. I don't need to because that would just be 0. So this is my my dividend, that's my quotient for the problem. So a reminder, when you get a remainder of 0, both the divisor and the quotient are factors of the original dividend. All right, let's do this last one here. Okay, remember with this -1 power, all that means is it's the same as being the fraction underneath or division. So I'm gonna strip away all the variables here. Notice I'm missing some terms. I'm missing the 0x cubed here, so I'm gonna put 0 in as a placeholder. I'm also missing a constant out here, a 0 out there. So I'm gonna put those two placeholders in. I'm gonna just list the coefficients, so 3, -5, -43. I'm sorry, I need to put in my 0. So 0, then -43, 6, and then my placeholder 0 again. I'm going to put in the box the opposite of this number here. That'll be a 3. Skip a line, draw a line, bring the number straight down. So this 3 comes down. We go 3 times 3 is 9. Add straight down, and I get a -5 plus 9 gives me a 4. 3 times 4 is a 12. We're going to add straight down, and I get a 12 here. 3 times 12 is 36, okay? Now that's a larger number, but now when I add it to the -43, I end up with a -7. -7 times 3 is -21. Add it to the 6 above it, and I get a -15. -15 times 3 is -45. Add it to the 0, and you get -45 for my remainder. So in writing this one out, I'm going to start with 1 degree less than the 5th power I've got here. So I'm going to start with the 4th power. So this will be a 3x to the 4th plus 4x cubed plus 12x squared minus 7x minus 15, my constant. The last one's the remainder, so I put plus -45 over my divisor, which is x minus 3. That's for my final polynomial division there. Now, what we want to do next is we're going to talk about this in terms of some different types of problems. We've done all of these where the divisor all had a leading coefficient of 1. So now we're going to start with doing a problem where the divisor has a leading coefficient that's not equal to 1. So we're going to try one like this where the leading coefficient is equal to 2. So let me tell you what the setup is for this and how we adapt to that. So what we'll do is for this we'll divide by the leading coefficient. And then at the end, our answer, we'll take it and we'll multiply the fraction at the end. We have the remainder over the divisor, multiply the fraction by that leading coefficient. both in the top and the bottom, both in the numerator and denominator. So when we take this problem here, we're going to go ahead and multiply it by a half over a half. So what you get here is 4x to the fourth minus, notice there's no x cubed term, so I'm going to have plus 0x cubed. Then minus 4x squared times a half is minus 2x squared. X times a half is plus a half x. Notice that we might have fractions involved in the problem as a result, and 4 times a half is plus 2. All over 1/2 times 2x gives me just an x. 1/2 times 1 is plus 1/2. So there I've got a problem now. This setup is just like the setup I used in the previous ones, because our leading coefficient of this divisor is equal to 1. Now we're going to take this, we're going to strip off the variables, make it 4, 0, -2, 1/2, and 2. And in the box, we're going to put the opposite, -1/2. Skip a line, draw a line. I'm going to bring the 4 down. So 4 comes down, 4 times -1/2 is -2. Add straight down, you get -2. -1/2 times -2 gives me a positive 1. Add straight down, you get -1. -1 times -1/2, ooh, I'm going to have on this one a positive 1/2. But notice I'm going to have a half plus a half. That gives me a 1. And then -1/2 times 1 gives me -1/2. Add straight down and you get a positive 3/2, or 1.5, because I'm adding a -1/2 to it. All right, so let's go ahead and write out our answer. So we go 1 degree less than the x to the fourth. We'll have 4x to the third minus 2x squared minus 1x, and then plus 1, and then plus our remainder, which this remainder here is 3/2, over our divisor x plus a half. Now that is kind of awkward because I've got a fraction in my divisor there. So one easy way to fix it is multiply the fraction by the leading coefficient. Do it in the numerator and denominator. So you can multiply this by 2 over 2, which is equal to 1. Doesn't change the value, just changes the form. So 4x cubed minus 2x squared minus x plus 1. 3/2 times 2 is equal to 3. 2 times this gives me 2x. A half times 2 is equal to 1. That's my original divisor. And there's my answer after taking care of that fraction by multiplying by the 2 over 2. So what we've done now is we've done a synthetic division to do all these different types of problems. We want to add just one more fact on that relates to this. And this is called the Factor Theorem. It doesn't have anything to do specifically with the synthetic division. Instead, it has to do with a theorem that helps us know how to get the remainder if we know the original problem. So an original problem like this, and this was example 2 on the previous page, x squared plus 14x minus 10 over x minus 6. So look back at example 2, you'll see that's our problem. We got this answer, x plus 20 plus 110 over x minus 6. What if we just want to know what the remainder is? We want to know that 110. Well, we've got a nice fact that happens with the remainder theorem. The remainder theorem tells us that if you take this 6 down here, that we're using an r here. It's not r for remainder, it's r for root. What would you put into this to make this equal to 0? So that's 6. If we put that into the function, what you get is you get the answer to, you get the remainder of the original problem, of the original function f of x divided by x minus r. That root, this would be x minus 6 here. This f of x would be this x squared plus 14x minus 10. So if you just want the remainder of this thing, all you have to do for this is put in 6 into that numerator, into the function itself. Let's do that. 6 squared plus 14 times 6 minus 10. 6 squared is 36. 14 times 6 is equal to 84. Then subtract 10. 36 plus 84 gives me 120. 120 minus 10 gives me 110. So notice this remainder is the remainder that we got when we did the whole problem. So if all you're interested in is the remainder, then you don't have to go through the whole synthetic division or polynomial long division. What you can do is you can just put the root or the number, the opposite of this one down here, -6 here, put a 6 into the function, and the result that comes out is your remainder to the problem.